everyone, welcome to MS British Academy. In this video, I'm going to solve Mathematics Paper 5 Probability and Statistics 1 of October and November 2022. So don't forget to share this video with your friends, and most important, please subscribe our YouTube channel. You will get amazing content here. So let's start this video. So the very first question is 50 values of variables are summarized by summation x minus 20 is equal to 35 and summation x square is equal to 25,036. So find the variance of these 50 values. So the variance symbol is sigma square, and sigma is only standard deviation. So n is number of variables. This is equal to 50. Summation x minus 20 is equal to 35 can also be written as summation x minus summation 20 is equal to 35. And now this summation 20 is noted here. The summation 20 a is a multiplies n, because we are adding 20 50 times, because the n is 50. So 20 into 50 is 1000. So summation x is equal to 35, and this 1000 will be right side, so plus 1000. So summation x is 1035, and summation x square 25,036 is already given in question. So variance formula is summation x square upon n minus x bar square. This is mean, and the mean formula is summation x upon n. So variance square is equal to summation x square upon n minus summation x upon n whole square. So after substituting the values of all these variables, we will get 25,036 upon 50 minus 1035 divided by 50 whole square, and after calculation we get sigma square as, or variance as, 32.32. So now question number 2. In a large college, 32% of students have blue eyes. A random sample of 80 students is chosen. Use an approximation to find the probability that fewer than 20 of these students have blue eyes. Okay, in a college, if there are 100 students, so it means 32 students have blue eyes, but we have chosen only 80. So now we have to find out the probability that fewer than 20 students have blue eyes. So what is that probability? So number of students who have blue eyes in a college is 32%. So the probability of students who have blue eyes is 0.32%, 32, and probability of the students do not have blue eyes, it is 1 minus 0.32, and it is 0.68. So the number of values, number of students is n, and n is equal to 80 is given in question. So let x, the number of students who have blue eyes. Okay, this is x, the number of students have blue eyes, but we have to find out less than 20. So x is less than 20, so probability of x less than 20, and it also can be written as, can be written like this: p z less than 19 minus 5, 19.5 minus u upon sigma. And what is z? So z is I explained here, z is equal to x minus u upon sigma, because we are using normal distribution here, and normal distribution is only valid for continuous data, but the student is not continuous. The student is one discrete data, 1 2 3 4 5. The student can't be 1.2 student, 3.5 student, 4.5 student. A student can be 2, can be 3, can be 4, like this. So because we have a discrete data and we are converting into a normal distribution, so we have chosen like this. So now we need to use continuous correction, because we have applied continuous distribution concept to approximate a discrete distribution. So x is equal to 19.5 instead of 20. Okay, we don't take 20, we will take 19.5. So u is you can see the mu is n times p and sigma square as n pq, but we need sigma only, so we will take under root of this, we will get sigma. So after substituting the values, n is 80, p is 0.32 and q is 0.68, so we get this 17.408, and after under root we get 4.17 and mu as 25.6. Now we will substitute these values here. Px less than 20 is equal to Pz less than 19.5 minus 25.6 upon 4.17, and after calculation we get z less than minus 1.462, and this can also be write as 1 minus p z less than 1.462, and we can also write this as 1 minus phi 1.462, and the value of this we have I write here from the table of normal distribution. So finally the answer will be 0.0718. Now question number 3, times the times t minutes taken to complete a walking challenge by 250 members of a club are summarized in a table. So the time taken in t minutes less than 20, so the cumulative frequency is 32, less than 30 66, less than 35 112, less than 40 178, less than 50 minutes 228, and less than 60 means 1 hour 250 members. This is a cumulative frequency. Draw a cumulative frequency graph to illustrate the data. Okay, so we have taken here in x-axis I have taken time, and in y-axis this is cumulative frequency. Okay, so I have started the time from 0, 5, 10, 15, 20, 25, 30, 35 and till 60, because we have to go till 60 minutes, means 1 hour. And frequency, cumulative frequency I have started from 20, then 40, 0, 20, 40, 60, 80, 100, 120, 40, 60 till 250 we have to go. Okay, so the B is okay. So see, when the time is less than 20, cumulative frequency is 32. Okay, cumulative frequency is 32. So here, and it is going to be 32. So I have marked here. So when time is 30, the cumulative frequency is 66. Time is 30, cumulative frequency is 66. So I have marked here. After that, when time is 35, the cumulative frequency 112 marked here. When time is 40 minutes, cumulative frequency is 178. 40, so 178 here. Time is 50, so cumulative frequency is 228, and when the time is 60, frequency is almost frequency is 250. Cumulative frequency is 250. After that, marking these all, I have made a smooth graph like this. Okay, this is a smooth graph. The second part, use your graph to estimate 60 percentile of data. 60 percentile of data, the value of time t at 60% of the cumulative frequency. So the 60% means 0.6 multiplies 250 of cumulative frequency. Okay, 250. So the value is 150 cumulative frequency. At 150, the time is how much? At 150, the time is 38 minutes. so 38 minutes. Now it is given that an estimate for the mean time taken to complete the challenge by these 250 members is 34.4 minutes. This is the mean, means this. It is given us mean value of these all 250 members is given. Calculate an estimate for the standard deviation of the time taken to complete the challenge by these 250 members. Now we have to find out the sigma. So the mean is 34.4, it is given. Now we will make class, cumulative frequency and mid values of class. So the class is 0 to 20, 20 to 30, 30 to 35, 35 to 40, 40 to 50 and 50 to 60. I have made these type of class here, and the cumulative frequency is 32, 66, 112, 178, 228 and 250. And the frequency is how this is 32. Now this is 66 minus 32, so it will be 34. 112 minus 66, 46. Now we will subtract this. Now 228 minus this, so we will get 66. Now 50, and from 250 minus 28, 22, we will get this like frequency. Now the variance formula sigma square is sigma m square f upon sigma f minus mean square. So m is this, the mid value, 10, this is 25, here 32.5, 37.5, 45, 55. So square of this multiply frequency divided by frequency sum. So 10 whole square, see, 10 whole square multiply 32, 25 whole square multiply 34 plus 32.5 whole square multiplies 46 plus 37.5 whole square multiplies 66 plus 45 whole square multiplies 50 plus 55 whole square multiplies 32 and divided by f whole square frequency divided by frequency summation. So we will add all these frequency and divide it. 32 plus 34, 30 plus 30, 46 plus 66 plus 50 plus 22 and minus 34.4 whole square because mean whole square and its value is 34.4 whole square. So after calculation we get sigma square as 151.24, and now we will take the under root of this because we need to find the standard deviation. So after calculation we get 12.3 as our standard deviation value. So now the question number 4. 3 fair 4-side spinner each have side labels 1, 2, 3, 4, and the spinners are spun at the same time, and the number on this side on which each spinner lands is recorded. The random variable x denotes the highest number recorded. Okay, so what is the question? 3 fair spinner are there and all spinner like this, and here is marking 1, 2, 3, 4. When the spinner spun this and the each spinner lands the record, the number highest recorded as x is denotes the highest number recorded. So the very first question is, the A part is show that px is equal to 2 is equal to this, means when the highest probability is highest number coming 2, at that time we need to find the probability. So x is the highest number recorded, x is equal to 2, so can be achieved by when first spinner 1, 1, 2, then 1, 2, 1, then 2, 2, 2, 2, 1, 1, 1, 2, 2, 2, 1, 2, 2, 2, 1. These 7 cases are possible. Okay, so then x is equal to 2, we will write p 1 comma 1 comma 2 plus p 1 comma 2 comma 1 plus 2 comma 2 comma 2 plus 2 comma 1 1 plus 1 comma 2 comma 2 plus 2 comma 1 comma 2 plus 2 comma 2 comma 1. Okay, so now px is equal to 2. Now the probability of getting 1, because we have four numbers 1 2 3 and 4, and out of these four values we are getting only one, like 1. So this is probability of all getting is 1 1 1 1 1. So we will write getting of 1. So 1 by 4 getting 1, 1 by 4 getting 2, 1 by 4. So we will multiplies and then sum. So after calculation we get px is equal to 2 as 7.64, and we have to show that 7 upon 64. So we get 7 upon 64. Now question number B, complete the probability distribution table for x. So the first question is when the highest number is getting only 1. So there is a one only possibility when all will get 1 1 1. So there's only one possible case. So x is equal to 1 means p is equal to 1 comma 1 comma 1, only one possibility. So 1 by 4 multiplies 1 by 4 multiplies 1 by 4, and I will get 1 upon 64. When 2 6 7 upon 64, 3 19 upon 64. Now we have to find out 4. So 4 we can find 1 minus using this 1 minus p x1 plus p x2, okay, p plus x3. So we can use this px1 plus px2 plus px3 plus px4 is equal to 1. So the value of p4 will be 1 minus 1 upon 64 plus 1 upon 7 upon 64 plus 19 upon 64. So we will get px4 as 37.64. So the table is complete. Now on another occasion, one of the fair four-sided spinner is spun repeatedly until a 3 is obtained. Now we are spinning to get 3. So the random variable y is number of spins required to obtain 3. So this is number of random numbers. So in the question it is given when we will spin the spinner 6 times, then we will get 3. So the find p y is equal to 6. Here use geometric distribution. Okay, so we are getting this, the getting 3 probability is 1 upon 4, and we are getting at 6th chance. Okay, we are getting at 6th chance. So the p is 1 upon 4 and q is 1 minus p. Okay, q is equal to 1 minus p. Q is equal to 1 minus p. So we will get 1 minus 1 upon 4. So this will be 3 upon 4. And p y is equal to 6. So we can use the formula using this. Y is equal to r. So q r raised to minus 1. Q r raised to minus 1 multiplies p 1. So we can use here. Now we can use this, and we will get, so q 5p and 3 upon 4 6 and 1 upon 4. So after calculation we get 243 upon 4069. Okay, now we need to find out p y greater than 4. So p y greater than 4 means p y greater than or equal to 5, because again we can't spin 2.5 times. We can spin 5 times, 4 times, 6 times, 3 times, 2 times. Therefore greater than 4 means equal to or greater than 5. So we can use this formula for finding out this. So q raised to 5 minus 1. So we will get 3 upon 4 raised to 4. 3 upon 4 raised to 4 and 81 upon 256. Okay, now question number 5th. A company produce bags of sugar. An inspector find that on average 10% of bags are underweight. Okay, 10 bags are chosen at random. Probability, find the probability that fewer than 3 of these bags are underweight. Okay, so probability P is probability of bags that are underweighted. So 10 means 10% means in 10 bags 1 bag is underweighted. Okay, so 0.1 is the probability that the bags are underweighted, and the Q is 1 minus P, 0.9. This is the bags those are not underweighted, and the number of n is 10. So use binomial distribution. So we will use Px less than 3. Px less than 3 means P either x is equal P x0, P x1 plus P x3. So we can use these three, P x0, P x1 and P x2. So 10c0 q raised to this 10c1 q raised to 10 minus 1 p1 plus 10c2 q raised to 10 minus 2 multiplies p raised to 2. So after substituting the values of all 10c0, 10c1, 10c2, pq, so we will get px less than 3 as 0.9293. Okay, 0.93. Now the weight of bags of sugar produced by company B are normally distributed with mean. Okay, the mean value is given 1.04 kg and standard deviation as 0.06 kg. Find the probability that randomly chosen bag produced by company B weighs more than 1.11 kg. So the mean value is given 1.04 and standard deviation is 0.06. Use normal distribution. The W is weight and this is n, so u comma sigma square. So W n, and now we can use P weight more than 1.11 kg. Okay, P weight more than 1.11 kg like this. W is greater than 1.11 kg. So the Z is W minus U upon this. Okay, you can use because we are using normal distribution. So we will calculate Z, and the Z is P W greater than 1.11. So the Z is greater than this value 1.11 minus 1.04 upon 0.06. So we will get PZ greater than 1.167, and the value of okay, so we can simplify this as 1 minus P Z less than 1.167, and we can write this as 1 minus 5 like this, and this value of this we can take from the normal distribution table. It is 0.8784. So final answer is 0.122. Okay, this is the final answer. Now 81% of bags of sugar produced by company B weigh less than W weight. Okay, W weight. So find the value of W. So W, this is a representation of weight and it's a weight kg, W kg. This symbols are different. This is capital and this is smaller. 1.04 comma 0.06 whole square. Now the P bags of sugar that are less than W kg is 81. Okay, 81%. So the probability is 0.81. Now we will use P W less than, okay, W less than W is this. Now PZ less than W minus 1.04 upon 0.06 is equal to 0.81. Okay, so we will take the value of this from normal distribution. So now this is 0.878. After calculation this will be go here in multiplication. So 0.878 multiplies 0.06, we get 0.05268, and now this one will go to right, and W is equal to 1.04 plus 0.05268. So after taking sum, we get W as 1.09 kg. Now question number 6, A. Find the number of different arrangement of 9 letters in word activated. Okay, so first we will arrange in alphabetical order. The A comes 2 times, then C, then T coming 2 times, I, V, E, D. Okay, I, V, T, A, D. Okay, or you can randomly arrange also. So A comes 2 times, C, then T comes 2 times, I is on only 1, V is only 1, E and D are different. So A is repeating 2 times and T is also repeating 2 times. So the number of arrangement that can be possible, 9 factorial upon 2 factorial upon 2 factorial. Why 2 upon 2? Because here are 2 similar and this is also 2 similar. So that will be in division, 2 factorial upon 2 factorial. Now find the number of different arrangement of 9 letters in word activated in which there are at least 5 numbers between 2 A's. Means there should be 5 letters in 2 ways and we have to make a 9 letter word. Okay, 9 letter word. So at least 5 letters between 2 A's means there could be 6 letters or 5 letters, 6 letter or 7 letters can possible between 2 A's. So the case 1 when only 5 letter between 2 A's. So the first case is A, then there should be 5 different letters, 1, 2, 3, 4, 5, and then A, and then left 2 positions. So then let's say there is not first position is empty, there could be any possible values. Now at second position there is A, so then again 5 different values in between A. So 1, 2, 3, 4, 5, and here A. Now let's say the first 2 position is left it empty. So the A, 1, 2, 3, 4, 5, and this. So we can make 3 possible cases in case 1. So in one row 2 A's are fixed, but other 7 letters including 2 T's are arranged in 7 factorial upon 2 factorial. And because there are 3 possibilities, so we will multiply this 7 factorial upon 2 factorial by 3 to get the total arrangement in case 1. So for case 1, total arrangement is 7 factorial upon 2 factorial multiplies 3 and its value is 7560. Now case 2, when there are 6 letters in between 2 A's. So the A's and there are 6 letters and the first position is left and there is second position and 6 letters. So for second case also total arrangement will be 7 factorial upon 2 factorial multiplies 2 and its value is 5040. Now the third case and last case, when 7 letters between 2 A's, so these are fixed and 7 letters in between this. So the case 3, total arrangement 7 factorial upon 3 factorial and its value is 2520. So now take the total of arrangement, sum of these arrangements. So total number of arrangements 7560 plus 5040 plus 2520, it's coming 15120. This much arrangement we can make or are possible. Now 5 letters are selected at random from 9 letters in word activated. Find the probability that selected does not contains more T's than A's. Okay, more T's than A's we need to select. So selection does not contains more T's than A's means number of T's are less than or equal to number of A's. So the number of T's is less than or equal to number of A's. So now selection of 5 letters according to question. Okay, so then random I can take 9C 9C5 without any condition, without this condition. But when we are taking this condition, so we need to do this when the number of T's and number of A's are the other 5 letters and the selection. So the first is we need to find out 5 letters from these 3 sets. We have 2 T's, we have 2 A's and other 5. So the first case I didn't choose T, I didn't choose A's, I only choose other 5 letters. So 2C0, 2C0, because this is 2 and this is 5. So 2 letters, 2C0, I didn't choose anyone. So 2C0, I didn't choose anyone, 2C0, and I choose 5. So 5C5. Now here, first case, now again I choose T as 0, but I can take now T as a 1. Okay, A1. So in 2 A's I choose 1, so 2C0, 2C1, and in 5 letters I choose 4, so 5C4. T0, but I choose A2, and the other is 3 because I only want to choose 5 letters, sorry. Okay, the 2 I have already chooses, so now I can choose 3 letters from other letters. So 2C0, 2C2, and 5C3, and so on. 1 comma 1 and 1, and 3, 1 2 and 2 2. So 2 comma 1 multiplies 2 comma 1, and here 3 comma 5 comma 5C3. Then I choose 2 comma 2C1, 2C2, and 5C2, then 2C2, 2C2, and 5C1. Okay, so now I need to total up, okay, sum of all these. So 1 1 1, so 1 into 1 into 1, then 1 value, and its value will be 2, and it will be 5. So 10, 1 and 10, then here 1 and 1, and this will be 10. So 10, it will be 2 2 and 10, so 40. So here it will be 2 1 and 10 20, and it will be 1 1 and 5, so 5. So after summation we get 86, and the normal selection is 9C5. So the probability will be of probability 5 letters selected and not contains more T's than A's. So it's 86 divided by 9C5, so 43 upon 63, and it's the final calculation 0.6825. Now question 7. Sam and Tom are playing a game which involves a bag containing 5 white discs and 3 red discs. They take turns to remove one disc from the bag at random. Discs that are removed are not replaced into the bag. Okay, it's removed but it's not replaced into the bag. So the number of the game ends as soon as one player has removed 2 red discs from the bag. Okay, so that player wins the game. Sam will remove first. So find find the probability that Tom's remove a red disc on his first turn. Okay, Tom remove the red disc on his first turn. So W is white disc and R is red disc, and the Sam dash means Sam does not remove red disc and Sam remove the red disc. Tom dash means Tom does not remove the red disc and Tom remove the red disc. But we need to find out Tom remove the red disc from his first turn. Okay, Sam will remove first. So see which possibility we can do. Tom remove a red disc on his first turn. So Sam will choose. Sam will start the game, and it possibility he will not get red disc. So this, and Tom played and he removed the red disc, or Sam also removed and Tom also removed. So the probability is 5 divided by 8, because in a bag there are 5 white discs and 3 red discs. So Sam does not remove red, it means he removed white one, so 5 divided by 8. And now the remove card is not replaced into the bag, so it's total 8, now it will become 7 because one card is removed. So when the Tom will play, there are only 7 cards, and in 7 cards 4 are white and 3 are red. Okay, 4 are white and 3 are red when Tom will play the game. So 3 divided by 7. Or when Sam also remove the red card, so 3 divided by 8. Now red card is removed and not replaced. Now when the Tom will play, there will be only 2 red discs and 5 white discs, so 2 upon 7. So after calculation we get 15 upon 56 and 6 upon 56, so the total is 21 upon 56. Now B part. Find the probability that Tom's win the game on his second turn. Now Tom win the game on his second turn. So Tom wins the game on his second turn. So the possibilities are Sam didn't get red disc, Tom get the red disc. Okay, this is the first turn, both of them played. Now again Sam will play and Tom will play. Sam didn't get in his first turn the red card, so here it can get. Okay, so but Tom need to get both of the time to win the second one. Okay, so Tom should get on his both turn as a red disc. So Tom will get this, get and get. But Sam will only get 1 times or 0 times. So here it get 1 times, here is also didn't get any time, and here it get 1 time. So Sam didn't get, Tom get, Sam get, Tom get. So in this case also Tom will win. Here also Tom will win, and in this possibility Tom will also win. So the probability Tom wins the game on his second turn is when Sam played, there were 8 discs, 5 white and 3 red. So he didn't get red one, so 5 divided by 8. Now there are only 7, 4, 3, and Tom played. Now Tom need to remove red one, so 3 upon 7. Okay, 3 upon 7. And when he played, there is only 4 white and 2 red. And now who played? Sam played, and Sam also removed red one. So red one, so 4, and it's 1 only. And again the Tom will play, and he also need to remove red one to win the game. So now in this box there will be 4 white and 0 net. Okay, so see, 5 upon 8, now there are 7 and 7, 3 upon 7, now there is 6, so 2 upon 6, now there are only 5, so 1 upon 5. So okay, in this way we will write the probability of all Sam and Tom getting or not getting. Okay, so in second case Sam is not getting, so 5 upon 8. Tom is getting, so 3 upon 7. Here the Sam is also not getting, again Sam is not getting, so the total will be 6, and the white ball there are 4, so 4 upon 6, and Tom will win because there are 2 red discs are there, and there are 5, total 5, so 2 upon 5. Now 3 upon 8, 2 upon 7 multiplies 5 upon 6 and 1 upon 7, because Sam removed in his first turn. Sam removed, so 3 upon 8. Tom also removed, so okay, he removed. So now the case will be 5 white 1 and 2 red 1. So 2 upon 7, and Sam did not get, it means 5 upon 6. 5 upon 6. 5 upon 6. And now Tom's need to remove this red one, so 1 upon 5. So after calculation we get Tom wins the game on his second turn, 30 upon 1680, 120 upon 1680, and 30 upon 1680, and the sum of all these is 180 upon 1680, and which is equal to 3 upon 28. So the probability that Tom's win the game on his second turn is 3 upon 28. Now find the probability that Sam remove a red disc on his first turn, given that Tom wins the game on his second turn. Okay, so which case I need to take? Sam remove a red card on his first turn. See, Sam remove a red card on his first turn. Here he didn't get, here he also didn't get. So this one I need to take, and probability provided Tom will win the game. So okay, probability Sam removed the first red card on his first attempt, so Sam removed this case, and total divided by total. So the probability of getting Sam red card on his first attempt is 30 upon 1680, and divided by 2 upon 28, which is equal to 1 upon 6. So the probability 1 upon 6 that Sam will remove red card on his first attempt, provided Tom will win the game. I hope you understood all the questions. So if you understood these questions, so please subscribe.